Alright, today is the last lesson of chapter 4, and it's an extension onto the side theorem, side, angle, angle, and angle, angle, side. We're now going to add hypotenuse leg onto those choices. So as written here, okay, we have our the regular triangle proofs we were doing before is you still had your red, green, blue congruent triangle, CPC, DC, and then whatever else you have. But for HL, so triangle proofs involving HL is only for right triangles, only. So just to kind of remind you what we're working with here for right triangles, HL stands for hypotenuse leg. So in a hypotenuse, remember, is across from the right angle. So that's the hypotenuse. And the legs of a right triangle are the sides of the triangle that form a right angle. Okay. So for HL, you need three things. So I outlined them here. You need a congruent leg, so that's a side. You need a congruent hypotenuse. And your third thing is what makes these proofs a little bit harder, is you don't need a third congruent part. You need to write that they are right triangles. So the other congruent proofs we did before with congruent triangles, you needed 3 congruent parts. HL is different. You need 2 congruent parts, specifically the leg and hypotenuse of the right triangle, and you need to write in your proof that they're right triangles for them to be proven. So I'm going to do some examples, like some algebra, or kind of getting you used to it. This one we're going to skip, so don't worry about that one. Here it says, what additional information do you need to prove the triangle is congruent by HL? So this might be on the test. So what I'd like you to do is star this question. So make sure you star this question because it's going to be on the test. Maybe right next to your star, on test. Okay, so write on test next to this. All right, so we are given C is the midpoint of BD and AD. So if C is the midpoint of BD, that makes these two lengths congruent. And if AE, if C is the midpoint of AE, it makes these two congruent. So we need to figure out what additional information do you need to prove triangles congruent by HL. Well, notice we have a leg and we have a hypotenuse. The third thing we need, if you look back over here, are your right triangles. So what you need to say is triangle ABC and triangle EDC are right triangles. What people mistake, like the biggest or the most common mistake for this one is they say angle B and D have to be right angles. That's not right triangles, it's just talking about the angles. So you need to make sure you write that they're right triangles. That's the part that people kind of mess up on this one. All right, this next problem is the systems of equations. Actually, no, this one's not. We're going to find the value of x and y. So I have to see which parts are corresponding. So notice I'm going to start with x. Okay, this is your a leg, longer leg out of the two. So this one is going to correspond with the longer leg on the other one. So 5x minus 7. If those triangles are congruent, then these legs are the same. So I'm going to have 2x plus 2 equal to 5x minus 7 and solve for x. So I'm going to subtract 2x from both sides. Then I'm going to add 7 and divide by 3. So my answer for x is 3. For my other side, for y, okay, this is on the hypotenuse, this is on the hypotenuse. If those triangles are congruent, then the hypotenuse is congruent, so I'm going to set these equal to each other as well. To solve, I'm going to subtract over my y, and then divide. So my y is 2. Okay. This is the one I was talking about. Okay. Kind of a hint that we're going to be doing systems because look at right here. We have that 2x minus y and an x plus, like x and y are in the same expression. So let's just start with that one. This is that short, it's like a short leg, so that's going to be corresponding with the other leg over here. So I'm going to set 2x minus y equal to x plus 4. And I can't solve that because I have x's and y's in the same equation, so I'm going to set up another equation. So I'm going to have 6y and 4x plus 2. So I have 6y equaling 4x plus 2. So what I'm going to have to do is I'm going to have to solve this using systems of equations. Now these aren't matched up right to use elimination, so I'm going to show you how to do this using substitution. Substitution is when you rewrite one of the equations to solve for a variable and plug it in the other equation. So what I'm going to do is I'm going to solve for x in this top equation. So I'm going to rearrange this equation so x is alone. Okay, so I'm going to write it underneath. So I'm going to rewrite it just so everything's by everything. And what I'm going to do is I'm going to subtract over x from that 2x, and then I'm going to add y to both sides. So my x equals y plus 4. Okay. So these two equations, okay, this one and the one I just figured out, I'm gonna put this here, this one, are exactly the same. All I did was rearrange them algebraically. So what I'm going to do now is I'm going to figure out what y is by substituting in y plus 4 in for x in my other equation. So I'm going to have 6y equaling 4, and in parentheses, I'm going to plug in y plus 4, and then plus, whoops. Oops, here we go. It'd be y plus 4, and then plus 2. So I'm going to distribute the 4. I get 6y equaling 4y plus 16. I'm going to combine like terms. I'm going to move over the 4y. And then divide by 2. So my y is 9. To figure out what x is, I can plug in 9 into any equation that has x and y. So I can do this one, or that one. I'm going to use the one I rearranged just because x is already solved for. So what I'm going to do, so this is the equation for x. So what I'm going to do is I'm going to plug in 9 for y, and then add 4. So x is 13. Okay, now let's look at some proofs. Okay. All right, so same as the other triangle proofs, you're going to write what you need to prove at the end. So I'm going to go triangle BEA is congruent to triangle BDC. Okay, and I'm going to start with red. So I have a congruent length. I have EB congruent to DB. Okay. And I'm given angle A and C are right angles. Now, before, in other proofs, we'd write that they are congruent. I mean, we're saying we're going to be using HL theorem, but sometimes you're not sure. So I'm actually going to come back to this. I'm going to move on to blue to decide whether I'm going to have to do HL right now. So it says B is the midpoint of AC. So that means that AB and BC are congruent. How do I know that? Because if I knew it was a midpoint, by the definition, that's what it says. Okay, so now this is the part where I look back. And I look at, can I prove these using HL? Okay, so that's when I have to look. Do I have a hypotenuse? Do I have a leg? Okay. Another way to tell if you're going to use HL, if you were to have these two angles congruent, for example, okay, this would be ASS. Remember, that's a swear, and mathematicians don't swear. HL works with ASS only if it's a right triangle. So, because I have a hypotenuse and a leg, so my hypotenuse in red, my leg in blue, for part 3, I'm going to say triangle BEA, and so write small, triangle BDC are right triangles. If you could guess what the reason is, it's the definition of right triangles. Okay. So now that I have these as right triangles, okay, I can say the triangles are congruent by HL. So the difference compared to the other ones is this step 3. You need the right triangles instead of another congruent part. So let's try another one. So write what you need to prove last. That hasn't changed. Triangle LMO is congruent to triangle LNO. Okay, I'm going to start with red. So I have MO congruent to ON. All right, so then green. Then we have OM perpendicular to LM. So OM perpendicular to LM. Okay, well that'll give me a right angle. So I said angle M is a right angle by the definition of perpendicular lines. We've seen that before. They also have ON and LN being perpendicular, so I'm going to say the same thing with N. So angle N is a right angle because I was told those two lines are perpendicular, so by the definition. And then just like that last one, I'm going to wait a second to do that one. I don't know if I want those angles congruent for like a side or side angle side or angle side angle or angle side. So I'm going to skip and come back to it. And I'm going to try to get another congruent part. Well, look, there's our go-to. So I'm going to write LO is congruent to LO by the reflexive property. And now I'm going to look back, go back to step 6. And if I look at it, it would be ASS. So that's not one of my congruence choices. So if I look at this, I have a leg that's in red and a hypotenuse that's in blue. So what I'm going to say is triangle LMO and triangle LNO are right triangles by the definition of a right triangle. So the reason my triangles are congruent by hypotenuse leg. Last one. Oops. I think is already done on your sheet, but if not, we're gonna do it anyway. So do what you need to prove. Put that last, so triangle JNP is congruent to triangle WPM. And here we go, we start off. We have JM congruent to PM. Moving forward, we have JP parallel to MW. So use the transversal that's touching both. And sure enough, we get some angles. So I'm going to say angle 1 is congruent to angle 2. And those angles, because the lines are parallel, are alternate interior angles congruent. Okay, this next step is done. Then we say angle 1 is a right angle, so it measures 90. So right angle to 90, that's definition of a right angle. And then if I look at part 4, part 6, and then 7, if 1 and 2 are the same and 1 is 90, what they did is they just plugged in the measure of angle 2 there. So this is going to be substitution. Then we have 90 to right angle, so this is definition of a right angle. And then here I am again. Like, am I going to say that if they're right angles then they're congruent? Well, I've already had they're congruent, so I'm betting they want me to say that they're right triangles. Yeah. So I'm going to say that triangle JMP and triangle WPM are right triangles by the definition of a right triangle. Finally, green's done. Now I gotta look at blue. What do I have here? Well, PM. PM is congruent to PM by the reflexive property of congruence. And we've already talked about how, since I have congruent hypotenuse, congruent leg, and right triangles, this is HL.